Dear student of class 11, now from today I'll start the mathematical induction, and this chapter is related to the AP and GP series. That you have to prove in this chapter, that you have to prove whether the AP or GP series, the given series, the AP or the GP series, given series are true or not, that you have to verify using mathematical induction. To use mathematical induction, what you have to apply is, first you have to satisfy the given equation or the given series, number series, by putting n is equals to 1. By putting n is equals to 1, that you have to prove the left hand side is equals to right hand side. After proving n is equals to 1 is true, then you have to substitute n is equals to m. And the last one is that you have to verify n is equals to m plus 1. The three steps that you have to do. Okay, if all the three steps are true, then we can say the given mathematical induction is true. In this way, by putting n is equals to 1, then putting n is equals to m, then n is equals to m plus m, where n is the natural number. Now let's start. Question number 8.1. 1 plus 2 plus 3 up to n is equals to n plus 1 divided by 2. Only this kind of problems are important in ISC class 11 or any boards. This you have to prove the sum of the first and natural number is equals to n plus 1 divided by 2, that you have to satisfy whether this is true or not, that you have to verify. Now, first of all, I'll substitute n is equals to 1, but before doing this, I'll consider let Pn. N is any natural number. Pn is equals to 1 plus 2 plus 3 plus dot 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 up to n term is equals to n plus 1 divided by 2. After this n term, the last term is considered as left hand side quantity and this one is right hand side quantity. Now then I'll write putting n is equals to 1 in LHS and RHS. Putting n is equals to 1 in left hand side and right hand side. Now our left hand side is LHS is n. If I substitute n is equals to 1, then the right hand side RHS is equals to n plus 1 divided by 2. Again, I'll substitute 1 over here. This is 2 over 2. Left hand side is 1, right hand side is 1. Therefore, LHS is equals to RHS. Then we can write therefore P1. P1 means n is equals to 1. P1 is true. The first step, it is satisfied. The left hand side is equals to right hand side. Then we can say the P1 is true. Now then we'll verify by putting n is equals to m. Now the entire series that you have to write in terms of n. Pm is equals to 1 plus 2 plus 3 plus dot 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 up to m is equals to m plus 1 divided by 2. And remember one more thing, if P1 is true, then Pm is also true. Always the Pm is true. Therefore, P1 is true, then Pm is also true. And these two steps in every questions that you have to do, these two steps, putting n is equals to 1 and n is equals to m. M is always true. The third step is very important. Now in case of third step, what you have to do is putting n is equals to m plus 1. Putting n is equals to m plus 1. Now it's a method is there how to write the series, the method that you have to follow. Now dear student, don't get confused with the series. Now putting n is equals to m plus 1, you just try to understand. First of all, I'll write this equation, this entire quantity by starting with Pm plus 1. Then 1 plus 2 plus 3 plus dot 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 up to n. plus, then I'll leave some space over here, equals to the same M series that you have to write, m plus 1 divided by 2, plus again I'll have some space over here. Now say, now how to fill up the space? Now we'll go to this equation. Now say, n is equals to n plus 1 means over here the last term is n plus 1. Then whatever you write, you just substitute n is equals to m plus 1 over here. But you are not allowed to write these things in examination. M plus 1. Whatever the quantity n is there, so putting n is equals to m plus 1, you'll get m plus 1. Then write m plus 1 both the side. Let's suppose if it is n square, then this one will be m plus 1 whole square. Then you have to write m plus 1 whole square, m plus 1 whole square. Suppose if it is 2n, then this one will be 2m plus 1. Then again to write 2m plus 1 into 2m plus 1. Whatever you'll get, you just have to write over here. Now then, you have to simplify this quantity. And after the simplification, in place of n, your answer must be m plus 1. Now then, I'll take from these two quantity, I'll take m plus 1 common. If I take m plus 1 common, then what remains inside? M by 2 plus 1. Now then take 2 LCM. M plus 2. But what we require over here? In place of n, we need n plus 1 divided by 2. This answer is given by this quantity, and your answer is, suppose now the right hand side is n plus 1 divided by 2. Your answer should be in terms of m plus 1. That is, in place of n, that you have to write m plus 1 within bracket. M plus 1 means we can write m plus 1 divided by 2. This is your correct answer. You have to convert, after the simplifications, that you have to convert the answer in this form. In place of n, that you have to write m plus 1. Now then, m plus 1 is already there, into m plus 2. I'll break this m plus 2. M plus 1 divided by 2. Now say, in our answer, this n is replaced by m plus 1. Now say, n in place of n, it is m plus 1. In place of n, it is m plus 1 divided by 2. After getting this, you can say, therefore, Pm is true, then Pm plus 1 is also true. Therefore, the given induction is true. This you have to write. This is the complete solution, and each and every question that you have to follow these 3 steps. Now the next question is sum of the square of the first and natural number. I'll apply the same method in this question also. In every question that you have to follow the same method. Let Pn is equals to 1 square, 2 square, 3 square plus ... n square is equals to n plus 1, 2n plus 1 divided by 6. Putting n is equals to 1 in left hand side and right hand side. Now in this case, the left hand side is equals to n square. I'll put 1 square equals to 1, and the right hand side is equals to n plus 1 into 2n plus 1 divided by 6. Over here also I'll substitute 1 into 1 plus 1 into 2 into 1 plus 1 divided by 6. 1 plus 1, it is 2. 2 into 1, it's 2 plus 1, it is 3. Divided by 6. 3 to the 6 over 6. It is 1. Therefore, LHS is equals to RHS. Therefore we can write P1 is true. Next, putting n is equals to m plus 1. Oh, sorry, putting n is equals to m, and the m series is always true. Pm is equals to 1 square plus 2 square plus 3 square plus dot 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 to m square is equals to m plus 1 into 2m plus 1 divided by 6. Therefore, P1 is true, then Pm is also true. The same statement again that you have to write. Now next is putting n is equals to m plus 1. And this third step is important. Putting n is equals to m plus 1. Now then, putting n is equals to m plus 1 means enter m series that you have to write first of all. Starting with Pm plus 1, start with Pm plus 1, then the entire series I'll write 1 square, 2 square, 3 square plus dot 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 up to m square. Then I'll leave some space over here like previous sum equals to m plus 1 into 2m plus 1 divided by 6 plus space that you have to leave over here. So then how to fill up this space? Putting n is equals to m plus 1, you just substitute over here what you'll get. If you substitute n is equals to m plus 1, then according to this you'll get m plus 1 whole square. M plus 1 whole square. So m plus 1 whole square. Now say, after the simplification of right hand side, what will be your answer? The answer is given by this quantity. Before solving only, you'll know the answer. But in examination, you can only verify the answer, but you cannot show these steps in examination. You just, in the right hand side, you just put n is equals to m plus 1. M plus 1, m plus 1 plus 1, then 2 m plus 1 plus 1 divided by 6. Now after simplification of this quantity, your answer should be in this form. Then only we can say it is true. Now I'll simplify this quantity. Now from these two expressions, what is common? I'll take m plus 1 common. Then what remain inside the bracket? M into 2m plus 1 divided by 6 plus m plus 1. Now then, I'll take LCM over here within a square bracket. I'll take 6 LCM. It is 2m square plus m plus 6m plus 6. After that, it will be m plus 1. It is 2m square plus 7m plus 6 divided by 6. Now we can factorize the numerator of the square bracket. What will be the factor? 6 2s are 12, 4 3s are 12. 2m square plus 4m plus 3m plus 6 whole divided by 6. I'll try to manage this quantity over here. Then it is m plus 1. I'll take 2m common. M plus 2. And I'll take 3 common to be m plus 2 divided by 6. It is m plus 1. Again we have over here m plus 2 common, then within bracket it is 2m plus 3 divided by 6. Now I'll adjust this quantity in terms of this formula. Say m plus 1. What we require next quantity? M plus 1 plus 1. M plus 2 is there, so I'll write m plus 1 plus 1. But what we require over here? 2 into m plus 1 plus 1. And 2m plus 3 is there, so I'll write this quantity is 2m plus 3. We can write 2 plus 1 divided by 6. Now after this we can write m plus 1 m plus 1, then I'll take 2 common from this 2. 2 common, it will be m plus 1 divided by 6. Exactly the whatever I've written over here, it's the same quantity we have after the simplification of say. You just compare these two. In place of n, we're getting n plus 1. So this is also true. Therefore, the conclusion, therefore, Pm is true, then Pm plus 1 is also true. Therefore, the given induction is true. The method is same, only the third part simplification is a little bit complicated. Now another question, question number 8.4. I'll do this question also by the same method. Let Pn is equals to 1 plus 2 plus 2 square plus dot up to 2 to the power n minus 1 is equals to 2 to the power n minus 1. N belongs to natural number. Putting n is equals to 1 in left hand side and right hand side. This one will be right, left hand side is 2 to the power n minus 1. Then I'll substitute 2 to the power n minus 1, that is 1 minus 1. N is 1. 2 to the power 0. Anything to the power 0 is 1. 1 is also belongs to natural number. That you have to remember. After the substitution, n is equals to 1. Whatever the number that you will get, it should be in terms of given set. Right hand side is 2 to the power n minus 1. 2 to the power 1 minus 1. 2 to the power 1 is 2. Minus 1 is 1. In this case also, left hand side is equals to right hand side. Therefore, you can write, therefore P1 is true. Next is putting n is equals to m. Then Pm is equals to 1 plus 2 plus 2 square plus dot 2 to the power m minus 1 into 2 to the power m minus 1. Therefore, P1 is true. Then Pm is also true. Now next is the putting n is equals to m plus 1. Putting n is equals to n plus 1. Again, I'll repeat. First of all, you just write the m series starting with Pm plus 1. Pm plus 1, then the same series 1 plus 2, 2 square plus 2 to the power m minus 1 plus, you have to leave some space over here, is equals to 2 to the power m minus 1 plus leave some space. Now how to fill up the space? You just substitute n is equals to m plus 1 over in the left hand side. Whatever the quantity you will get, you just write over here. Now say, the left hand side is 2 to the power n minus 1. Raw fork I am doing over here. Now if I substitute n is equals to m plus 1, what I'll get over here? M plus 1 minus 1. What I am getting? 2 to the power n. This blank space we can write 2 to the power n. That means adding 2 to the power m on both the sides. Okay. Now then, now you have to simplify this quantity. And what will be your answer? Answer is given by the right hand side. The right hand side is 2 to the power n minus 1. You just substitute n is equals to n plus 1. What will you get? Your answer should be this one. Simplify this and try to manage this quantity over here. Now then, I'll simplify. 2 to the power m plus 2 to the power m means we can write 2 into 2 to the power m minus 1. Now then, I'll use the laws of indices. It is 1 over here. The base is same. Then we can write 2 to the power m plus 1 minus 1. Same quantity we are getting. Now, after getting this, the statement, therefore, Pm is true, then Pm plus 1 is also true. Therefore, the given induction is true. Dear student, I do hope you will understand these things, the concept of mathematical induction. Now, tomorrow I'll solve some numerical in a paper, then I'll send it to you. You just go through that paper, okay, and try to understand. This much for today.